third generation saw more data, not real fast, but certainly the internet was coming in the early 2000s, very, very late 1990s. And that really kind of changed drastically in late 2007, 2008 with the introduction of the iPhone. Now the phones are really beginning to use data. And third generation systems, remember it was circuit switched, it was packet switched, you had wideband CDMA, but that really couldn't handle the amount of data. So there was an entirely new architecture that was thought of or specified for release. Time frame here is roughly 2008, 2009, just before 2010. So yeah, a lot of motivations. There's an ever increasing amount of data. It doesn't show it down here, but back here there was even a lot more data. Today it's even more so. Third generation systems had a circuit switched core network, had a packet switched core network, had a circuit and packet switch decisions made here at the radio and on the radio access network. So again, that wasn't real efficient. The specifications were getting complicated, and we needed better. What was needed was better modulation, better efficiency, more bits per hertz to this ever increasing amount of data. So there was a new architecture, and that was the fourth generation. The fourth generation was called the EPS, or the Evolved Packet System, also known as, that's what AKA is, also known as LTE, and the time frame is roughly 2008, 2009. So again, like any generation, there's three main parts. You have your user equipment, your radio access network, your RAN, and then your core network. So the user equipment, which was called user equipment in 3G, was called user equipment in 4G. Very good. The radio part, you had in second generation, the cell tower was called the base transceiver station. It was called the node B, for whatever reason, not sure, for 3G systems. And these were connected to a radio network controller. This now in 4G became the enhanced node B. And it's all rolled into one. The controller and the cell tower was basically in one unit. And then instead of a separate circuit switched core network and a separate packet switched core network, this was the new network called the Evolved Packet Core. That's what we want to look at now, the Evolved Packet Core. What happened there? Now, a key thing to remember is that 4G, 5G, and every G from now on is data only. So you have to handle circuit type of services like voice, circuit read services like call forwarding, call waiting. Those are called supplementary services. Services like short message service have to be handled differently. They're still used, but again, they're handled a little bit differently. So this was the architecture for 4G. Your user equipment, which now could have been a smartphone, laptops, tablets, and even IoT, Internet of Things. These are those thousands of sensors out there measuring everything from traffic patterns to water pressure and oil pressure and everything else. It's called the IoT, the Internet of Things. So this is your RAN, your radio side. Your user equipment. Your RAN, your radio, is now called the Enhanced UTRAN, and it's now the E-Node B, the Enhanced Node B. Now, where they came up with the name Node B or Enhanced, not a clue. The signaling part of this is called the mobility management entity. When you power your mobile phone, signal's going to go over the air interface with your identity, your international mobile subscriber identity, and it's going to send a message up to this mobility management entity. The mobility management entity is now going to ask the home subscriber server about some information for you. Kind of like it did in 2G, 3G, where your mobile switch checked its own internal visitor location register and then got information about you from the home location register. It's kind of the same thing. The mobile switch and visitor location register is now, that function is now done at this device here, the mobility management entity. And instead of a home location register, it's called a home subscriber server. There is still an equipment identity register, which keeps track of the hardware. One of the big changes here, though, in 2G, 3G, that's that communication to the home system or to the home location register, that was SS7. This is diameter, whole new protocol. You also have a connection here to these two devices. In 2.5G networks, you had a serving GPRS support node and a gateway GPRS support node, SGSN, GTSN. Those are now replaced with what's called a serving gateway and a PDN gateway. The question was asked the other day, can you change P gateways? Normally not. Normally you've got to stay within the same P gateway. This PDN gateway is what assigns you your IP address. And you build a data tunnel from here to here, and you build a data tunnel from here to here. If you move, if this mobile starts moving and you go into a new S gateway, it'll build another, or if you go to a new cell tower, a new E node B, it'll build a new data tunnel here and keep this the same. If you move to another serving gateway, it'll build another tunnel from the P gateway to here, but you maintain your IP address because it builds these data tunnels. So normally, no, you're going to keep that same P gateway. Now, another function or another thing that happens in 4G is this policy and charging rules function. You can apply different policies. Policies are how do you charge the mobile? What's your guaranteed bit rate? Your quality of service, your latency or your delay, all these things that are affecting the data streams in there can be affected by this policy and charging rules function. If you're just out there doing www.google.com, that's not really a guaranteed bit rate, but if you're using your mobile phone to talk packet data, you have a higher guaranteed bit rate, so you have higher quality of service. So this can affect these different data streams. We'll get more into that. We can do that on other classes. This is a diameter interface only. So your primary protocols then are diameter, here, and here, and here, and here, and here, GPRS tunneling protocol, GTP, because it builds these data tunnels and you pass those data packets inside those tunnels or those pipes. Now, it's not always a one-to-one. You can have different E node Bs out here on the radio side, and they can communicate to different mobility management entities, which can communicate to one or more physical home subscriber servers. You can have multiple serving gateways serving different cells out here and multiple PDN gateways going out to the packet network. So even though this shows a kind of a one mobility management entity, one serving gateway, one PDN gateway. PDN is packet data network. There can be multiple of any one of these. There can be multiple of any one of these types of devices. So this is the function of them. Again, you still have to do things in a network, no matter what generation you are. You still have to access the network. The network still has to keep track of you, know what you're doing. It still has to build you. It still has to page you. It still has to authenticate you. It still has to update your location. All of those functions still happen. It's just that they're done in different entities and they're done with using different protocols. So again, your user equipment can be any one of these devices. Your E node B, which is your RAN, it's now called the Enhanced UMTS Terrestrial Radio Access Network, kind of a big acronym within an acronym. This is the overall architecture of your radio network. Your mobility management entity is the replacement of the mobile switch and the VLR, the Visitor Location Register, that was in 2G and 3G. So this is responsible for mobility and session management. It's responsible for your control plane. It manages your authentication through your home subscriber server. It understands a lot of protocols. It talks a protocol called S1. This is the S1 interface. So S1 application protocol here. It talks GTP here. It talks diameter here. So this is like it's like someone that speaks 3 different languages. That's what the mobility management entity does. This is still a holdover. The equipment identity register is a holdover from the 2G, 3G days. Yes, please.
Sorry, but I was interested. I was interested to know the type of protocol they use, maybe from the E node B to the mobility. Could it be a different one instead of the protocol you just
S1AP?
Yes.
No. I mean, if individual network wanted to do that, but the standards, the 3GPP standards, specifies this as S1-AP.
Okay.
So that's a whole separate protocol. It only talks to these mobility management entities.
Okay, and it applies to the other protocols as well, from the mobility management to home
Yeah,
system.
S1AP, but that S1AP is only from here to here. Once it gets here, this is a diameter protocol here or here. This is GTP here.
Okay.
This is GTP here and GTP here.
Okay.
So the policy, we won't talk anymore about the policy. This is the source for policy control. This sends diameter policies down to here to tell the PDN gateway how to handle different data streams. Okay. Now the S gateway, the serving gateway, this routes and forwards your user traffic. It's your inter-ENB. So if you go from one E node B to another cell site out here, it's going to be responsible for setting up the new data tunnel here. So that's part of its responsibility. And it's also for any kind of lawful intercept. Certain countries, the law enforcement is allowed to, with a court order, like in the United States, if they have a court order, they can listen in on conversations. Let's say they have the court say, okay, we're tracking this one person, we want to listen. And law enforcement can do that. And the intercept point of that would be in the serving gateway. So again, that's a whole nother thing called lawful intercept. The PDN gateway this connects to the Evolve Packet Core, connects this to the external IP network, TDP multimedia subsystem or some other packet network. It also is the one that allocates the IP address to the mobile, and it enforces the policies that come down from the policy and charging rules function. So again, this is just kind of an overall each one of these units or each one of these nodes do in a 4G network. So the functions are still there, what you did in 3G, except it's a little more concise now, and it's the key thing to remember, it's data only. I don't want to talk about these. These are just the new identities. Within the 4G network, you have new identities in the mobility management entity, and you have new identities in the mobile itself. So we're just going to leave these for reference because, again, it gets to be a lot of acronyms. Just understand that LTE has some different identities. Remember we talked identities way long a couple months ago. Yeah. We talked about the IMSI, the temporary mobile subscriber identity, the IMSI, the international mobile subscriber identity, the mobile station roaming number. These are all just types of identities. And again, this is kind of the same thing here. So there are identities, new identities that the mobility management entity uses with LTE and that the mobile uses. Okay, we'll just kind of leave it at that. Just understand that there are new identities with 4G. Now, this is a key thing. The protocols have changed. The protocol here, we said, was an S1 AP, S1 application protocol. However, this device that replaced the mobile switch and the VLR talks diameter now. Whole new protocol. It's a diameter protocol here. It talks GTP here. Now, GTP is GPS tunneling protocol. Think of a tunnel or a pipe. And inside that pipe, the data packets go. But there's a control piece and then an actual user piece. The user piece is that pipe that you're going to send data on. This piece here is a control piece. So what happens is this device will, once it sends a diameter message here, hey, here's a new mobile in my network. The HSS is going to say, I want you to set up a data pipe to the internet. So it'll come down here and it'll say, I want you to set up a data pipe here to the internet. And it does. It sets up a data pipe here. The next thing it does is it sets up a data pipe here. So when this subscriber types in www.google.com, that goes inside that pipe to here. It goes inside that pipe to here, and it's delivered to the internet that way. So just think of a packet inside of a data packet. It's a packet in a packet. And that's a tunneling protocol. And there are several tunneling protocols out there. The one that's used in mobile networks is called GTP, GPRS Tunneling Protocol. It's been around since 2.5G. It was around in 3G. It's here in 4G. It's used in part of 5G. Tunneling Protocol, GTP. So when you're roaming, if this subscriber is roaming here, this is their visited network. This is their home network. This is the visited public land mobile network. This is the home. So you get on a plane and you fly, let's say you fly to Dublin. And now you get off in Dublin, you power your mobile phone on if it's a 4G system. This is going to send a signal over the air, which is going to send an S1-AP message to the mobility management entity. Mobility management entity has to now find out something about you. So it's going to send a diameter message. Sorry about that. Send a diameter message back to the home network. And the home network's going to say, okay, Raphael, these are the services he subscribes to. And it'll also say, I want you to set up a data tunnel back to my home network. So the message would come here. The serving gateway would then set up a tunnel from Dublin back to Accra. When you access data, you access from your home network. If you access from your own network or from the visited network, that would be called local breakout. In that case, you would access the serving gateway, and this packet data network gateway would be in the same network. Then you would access the data network right here. But for data, virtually every network, I never want to say 100%, but virtually every network routes data back to your home network. If you place a call, you use the services of the visited network. If you use data, you go back to your home network, and your home network monitors your data. So your policies are delivered down here. So in your home network is your equipment identity register, your home subscriber server, and for home routing, your PDN, packet data network gateway.
Hello.
Mm-hmm.
Yes,
Sure.
I was interested to know if we are accessing data and it takes us back to our home location, this one. And then is it not like inefficient in some sense, or like are there some bottlenecks that will make it inconvenient? Hello, Steve.
Are we back now?
Yeah, we are back now.
Okay. So that's the data tunnel called for interconnection. Now, you still have to do circuit services. So if 4G and beyond is strictly data, how do you handle things like voice? How do you handle short message service when you are 4G? Well, there's a couple different ways. So LTE is data, only data. The long-term solution is something called VoLTE, voice over LTE. We'll talk about that in a minute. But in the interim, you can always do third-party providers. Now, the telephone, the mobile network operators would not suggest you always do this, but you can always do OTT. What's OTT? WhatsApp is OTT. Used to be Skype. I think they're out now. All these different other devices or other applications like WhatsApp. That's it's called OTT is over the top. That's one way you can do it. Another way is called circuit switched fallback. And there was a third way called voice over LTE generic access that really didn't go anywhere. So really the two ways today that you can handle circuit type services is right here. Circuit switch fallback, and the long term is what's known as voice over LTE. Let's take a look at those. What circuit switch fallback says is this. Circuit switch fallback says if a mobile network operator keeps, for a while, they won't do this for a long time, but for a while, let's say they keep their 2G, 3G network and they're in the middle, they're putting in the fourth generation. So they keep their 2G, 3G, and while they're starting to put in 4G, you can always do what's known as circuit switch fallback. What that does is it connects the mobility management entity through an interface to the mobile switch. And that is called the SGS, capital S, capital G, small s. That's that interface right there. And it uses a separate protocol. That protocol is SGS application protocol. So this connects up, and basically what happens is the mobile registers itself, does an update location on a 4G network, and it updates you on a 3G network, 2G, 3G network. The E node B will command the mobile, I want you to retune to a radio channel here so you can accept this call. Or if you're placing a call, if you're originating a call, the E node B will say, it commands the mobile to retune to a frequency so it can place a call or originate a call. So everything, there's a connection now between the existing 2G, 3G and the mobility management entity. It's called CSFB, circuit switched fallback. Now, it also has a separate protocol, SGSAP. So remember, this mobility management entity, it has to talk S1 application protocol. It talks diameter to the home subscriber server. It talks GTP to the serving gateway. And now if you use circuit switch fallback, it talks SGS application protocol to here. That's an interim solution because the day is going to come when these networks that want to get rid of 2G, 3G altogether. Remember, 2G, 3G is circuit switched, it's packet switched, it's two different radios, it's complicated. They want to stay on 4G. 4G is much better for data, but you still have to handle voice services. So one way is circuit switch fallback, but there's another way. The long-term solution is what's called VoLTE, voice over. In 2003, 2004, but now with LTE being data only, this is the way you can connect up to circuit switched world or packet switched. So now you use these GTP tunnels here to carry data into the IP multimedia subsystem. So LTE is using the LTE architecture to deliver messages to the IP multimedia subsystem, which then is used to set up a voice call. So it would just this same slide in a little more detail would look like this. This device now, this mobile device talks a protocol called SIP. SIP is Session Initiation Protocol. That's in the mobile itself. That SIP protocol would go over the air interface right here. The E node B would then send SIP signaling through that GTP tunnel to the serving gateway. The serving gateway would send it to the PDN gateway. The PDN gateway would then send it to the IP multimedia subsystem. This network now can handle voice over IP calls, or it can hook you up or connect you to a circuit switched call also. So if you're placing this, if you want to terminate at a network that's only circuit switched, the IP multimedia subsystem can do that. Now, anytime you use data though, if this subscriber does www.google.com, that goes over the air interface. www.google.com goes through that tunnel. www.google.com goes to that PDN gateway, either in that network or your home network, and then it's delivered to the World Wide Web. So your data on these networks goes through those tunnels. If you're setting up a voice call or some kind of circuit switch service, this will deliver that to this IP multimedia subsystem, which is made up of SIP servers, and we can talk more about this in other courses, application servers, media servers for voice type of announcements, gateways, which will convert one signaling to another type of signaling, depending on whether you're terminating at a packet network or a circuit switch network. So this is the long-term solution for both 4G and 5G, is voice over LTE. Now, we don't want to get into too much more detail, but just in telecom, you'll hear this term. But these data tunnels are not delivered data to the World Wide Web, delivered to the IP multimedia subsystem, or to other packet networks. Now, it's now getting to be 2016, 2017, 2018. The Evolved Packet System has performed well, but it was designed for broadband. There was no service flexibility. You can't introduce different parameters, different topology. The topology is what's defined here. All of these interfaces are point-to-point. The MME talks point-to-point to the HSS. The mobility management entity talks point-to-point to the equipment identity register. The policy and charging rules function talks point-to-point to the PDN gateway. The serving gateway talks point-to-point here, and so on. So these are all point-to-point protocols, that's true in 2G, 3G, and here in 4G. A lot of different signaling protocols. Think about it. We just mentioned that. What is this mobility management entity? What kind of protocols does it have to understand? It understands S1 application protocol here. It understands diameter here and here. It understands GPS tunneling protocol here. If you have circuit switch fallback, it has to talk SGS AP application protocol. A lot of different protocols. So many different signaling protocols. These functions are non-orthogonal. In other words, these functions are distributed here, and you can't move those functions around. What an MME does is what an MME does. What an EIR does is what an EIR does. So again, it's performed well, but it's not flexible. Oftentimes, functions hide the entire context. In other words, what it knows about the entire call. They hide that in certain devices, and in order to bill properly, they need to get access to those devices or to those parameters. Policy was somewhat limited, access was somewhat limited. So again, yes, it's performed well, but there was a need for a next generation, and that's where fifth generation came in. This is now, the time frame here is 2018 up through 2017 up through right now. So what's different now about this and 5G? Let's take a look. Why? Again, we've looked at, every time we look at a new generation, we look at motivations. What's the motivation for a fifth generation? One of the things is this need or this demand to connect everything, not just mobile phones anymore, many more IoT, Internet of Things devices. Remember, these massive amounts of sensors. Other use cases too, other things like autonomous cars and just things that need lower latency. There's just a demand today to connect everything up and using the mobile networks. A lot more machine to machine communication, a lot more Internet of Things applications, much more and better, higher definition video, virtual reality or augmented reality, artificial intelligence, sensors, 3D video, a lot things today that back when I first got my first mobile phone back in the late 1980s, I wouldn't have dreamed of doing this. Back then I was thrilled just to be able to move and have a phone. Now to do all these things, more and more data, and the need for more capacity in new markets. So the fifth generation now is a completely different architecture from 4G, which is a different architecture from 2 and 3G. So instead of just faster and faster and faster broadband, the ITU, the International Telecom Union, thought of three overall uses for 5G. One is faster broadband, faster mobiles that are very fast, downloading videos. That's they call that the evolved mobile broadband. But another part is what's called ultra reliable low latency communications. Ultra reliable, this has to be reliable. Low latency, this has to be virtually no delay, almost instantaneous. Think of things like factory automation. Think of things like autonomous driving. Think of things like robotic surgeries. Maybe the surgeon is in one city or one part of a city, and he's performing a robotic type surgery. That's the type of things that has to be ultra reliable. You can't have any delay. You can't have the core network cannot delay anything. But there's a third use. Yeah, please. Mhm. Are these things happening? Are these things really happening? No. And that's one, well, there might be a little bit of that, but this is one of the things about 5G. 5G has been out since 2018. Many networks are keeping their 4G network and upgrading the radio side, maybe so it's a little faster on the radio side, but they're not doing their core network. They're when 3G, when 4G came out, they couldn't put in 4G quick enough because 4G was needed for faster data. 5G is out now, and it's kind of just a little bit here, a little bit there. No, so they have the thing with 5G is they have all of these use cases. It can do this, it can do this, it can do this, it can do this, but everyone's kind of doing this. Everyone's yawning because again, it costs a lot of money to upgrade. Cost a lot of money to upgrade. Now, is it completely dead? No, of course not. Because the architecture, ultimately, I think cost will win out. Because this is a software-defined network. And being a software-defined network, you don't have these dedicated pieces of hardware. I think that will win out at the end. Let's take a look at the architecture. Because the other piece of this is massive machine communication. A lot of this happens today. This is where you have sensors that just send out little bits of data here and there, little bits of data. So if there's latency, if there's delay in massive machine communication, who cares? You're sending out a pressure, you're sending out a traffic signal, you're sending out something, a little delay wouldn't hurt it. Whereas this type of application, you can't have any latency, you can't have any delay. So there's three overall uses: massive machine type communication, ultra reliable, low latency or low delay communication, and then faster and faster and faster broadband. So how do you achieve this? How do you achieve this? You still have three areas. This is your user equipment, which can be a whole host of things. Your access technology can be a 5G radio, which is called the 5G new radio. It can also be a 4G radio that has been upgraded so it can talk to a 5G core network. You can have LANs, you can have non-3G PP. So again, you can have a lot of different accesses. But inside the core network, you've got functions, software functions that provide services. And these services are offered to other functions. So this device here, this authentication function would tell everyone else, here's what I'm capable of doing. And you can you can consume one of my services. Same with the network resources function, the policy, application functions. There's many different functions there, and these functions talk to each other over a common HTTP2 type of protocol. It also does, there's new concepts called, you can have virtual networks. So you're only using certain pieces of the network. On a 4G network, if you're a little IoT device, you're a little device out there that twice a day you send out 100 bits of data, that's it. You still have access to the entire network in 4G. You're a device out there, you have the use of the entire network. Here, it'll just slice you. It'll slice you into just certain functions that you need for that particular service. So it's a service-based architecture. These functions can exist anywhere. These functions can be right in the network. They can be in the cloud. They can be anywhere. So you're not confined to a central switch. These functions which communicate over HTTP protocol. The other thing about 5G is there's a strict separation between control and user. This user is called the user plane, and a GTP tunnel is set up from here right to there. So just as a kind of a high level look, in older networks, we had these entities, network entities. Network entities are now network functions. You're still doing much of the same thing. You still need to authenticate the user. You still need to manage the user. You still need to update their location. You still need to manage the session. All these things are still taking place. It's just that now they're being done with software defined network functions. These network functions could be located at the customer premises if you need very low delay. They could be located at the radio access network. They could be at the edge of the network, or they can be in a national or regional data center. Service-based architecture focuses on service, not on point-to-point designs. Network functions use services. So what they are, they're consumers. They also offer their services, so they're producers. You have producers of services and consumers. You might consume someone's and someone else, you produce something for someone else. So you're both a consumer and a producer. All the protocols that we've seen earlier, S1AP, SS7, diameter, S1AP, that's where the cell tower in a 4G talks to the mobility management entity. LCS has location services. SBC, that's for session closed service group. That's for session broadcast. SGS, that's for circuit switch fallback. SV, that's a whole different protocol for what's known as a single radio voice call. GTP are now reduced to HTTP. GTP is used though, it's just on the user plane. So these are just, now we don't have to go over these. I just want to point out what these things are. So you have these functions in the control side up here. These are software functions, and you can see what it replaces. This access and mobility management software function replaces the LTE mobility management entity, the mobility and access part. The session management function is the control plane part of the serving gateway, and it manages what was the management of the MME. This was the evolution of the policy function and so on. The HSS, the home subscriber server, is replaced by this unified data management. So again, we don't have to read and go over each one of these. It won't make a lot of sense now, but just keep in mind that for 5G, it's a software-defined architecture. You don't have these dedicated pieces of hardware like you saw in 2G, 3G, 4G. And the user part, the user plane, is separated from the control plane. GTP is still used here to here. This device is right here. This function is responsible for talking to the user plane function and setting up that GTP tunnel out to data networks. So again, I don't want to go into more detail than that, but that's what's happening in 5G. There are some different identities. UMTS, GSM, LTE. Remember, your hardware identity was called the International Mobile Equipment. Yep. Question? Mm-hmm. Yeah, these software functions can reside in the cloud. They can reside on a server, and that server can be located anywhere. That's true. Yeah, HTTP is. Now there's some other security concerns, and we don't have time to go over those, but there are some there's different enhanced security of 5G also. Okay, excellent. So this is just showing some of the identities. Your telephone number has always been known as your mobile station ISDN number. Now it's called the GPSI. Your IMSI, your International Mobile Subscriber Identity, it's still there, but now it's your private identity, concealed identity. Again, that's just but it's still there, but it's just called this private and concealed identity. And this is your global telephone identifier, and that's now called the 5G global. That's your temporary number that's assigned to you. So again, not important here, but just keep in mind there are some different identities or some changes in the identities. So let's take a little review. Let's just take a few minutes and review. You've had these different eras. We've been talking about this now for several weeks, from the 1980s, the 1990s, the late, all the way up to here. We've gone from phones that weighed a couple of kilograms all the way up to 5G. They've called these things, first generation was a variety of things. Second generation was called GSM. 2.5G was called General Packet Radio Service. 2.75G, right around this time frame, was called Enhanced Data Rate for Global Evolution. 3G, turn of the century, 1999 timeframe. UMTS, Universal Mobile Telecommunications System. That was increased with high-speed packet access until you got to 4G. 4G release 8, 9, 10. That became known as LTE. Then that got advanced with LTE Advanced. Today it's called New Radio and Next Generation Core Network. So you've got different eras, different generations, and just what they call things different. This is going back now to what we talked about several weeks ago, back from 1G all the way to 5G. 1G is pretty much gone today. 2G and 3G they're out there, just not as common. This is still very much in use today, 4G and now increasingly 5G. So this is a summary now of the generations and who is responsible. First generation, everyone. There was all kinds of different technologies, AMPS and total access communications, enhanced total, Nordic mobile telephone, all kinds of different technologies. Second generation, European Telecom Standards Institute, and the United States was TIA, which is Telecommunications Industry Association, Electronics Industry Association. Again, all kinds of different second generation systems. There was a lot of them. This was predominant though. GSM really kind of ruled. And then you got enhanced with 2.5 and 2.75G. 3G, a couple things happened at 3G. The standards now were at 3GPP, third generation partnership project, or 3GPP2, third generation partnership project numeral 2, or IEEE. So these were the technologies for 3GPP. This was the technology for 3GPP2 and then mobile WiMAX. And these got improved also over time until you got the 4G. 4G, there was two players in the world. The third generation partnership project, third generation partnership project 2. And in 2008, 2009, Ericsson pulled out of any support for UMB, this ultra mobile broadband. They abandoned that. So this went nowhere. No company in the world went UMB for 4G. Everyone went 3GPP LTE. So the world now, there's no But from fourth generation and on, and now fifth generation, there's no other players in the world. Everything in 5G and 4G is third generation partnership project. There's no other competitor like there was in 2G, 3G. Now, the last slide, this is kind of this might be like, whoa, a little overwhelming, but let's just spend 5 minutes on this. You got a second generation, a third generation, a fourth generation, and a fifth generation. Now, I didn't draw everything. I didn't draw all the architecture, but this is for the signaling. Now, the top part we're going to call the visited network. Let's say you're roaming, and this is your home network. If you're in a 2G system, your signaling protocol, if you're in your own home system, is SS7. If you are roaming, it connects SS7 back to your home system. If you're in a 2G system, your primary signaling protocol, signaling system 7. Okay? 3G. 3G, if you now connect up to a serving GPRS support node, we know you still have a circuit switch side. Your serving GPRS support node still talks SS7. If you're roaming, it talks SS7 back to your home system. However, for data, you have a data tunnel built between this cell tower and the serving GPRS support node. If you're in your home system, you have GTP to the gateway GPRS support node, and then you talk to the packet network. If you're roaming, the serving system has your serving GPRS support node, and it sets up that GTP tunnel to the home system, the gateway GPRS support node in the home system to the packet network. That's 2G, 3G. You get to 4G. What have we got in 4G? Well, a couple things. You got a mobile phone that talks SIP. So the 4G, you talk GTP to the serving gateway. The mobility management entity gets that information from the home subscriber server. That's diameter. So your diameter protocol is here. That mobility management entity tells the serving gateway to set up a data tunnel. That data tunnel, if you're in your home network, is right here. And you can either talk to the packet network or to the IP multimedia subsystem. If you talk to the IP multimedia subsystem, inside of there is SIP and diameter. If you're roaming, the serving gateway sets up a GTP tunnel to the P gateway back here, and that also is SIP. So SIP is inside those data tunnels. That's what I meant with that little dot inside. If you're using it just for the internet, www, then SIP would not be inside it. It'd be www.google.com. But for 4G, the mobility management entity manages the mobile with diameter. If you're roaming, it's diameter. By the time you get to 5G, you set up a GTP tunnel from the cell tower to the user plane function, and then you talk either to the packet network or you talk to the IP multimedia subsystem. If you are roaming, the user plane function in the visited network uses GTP to the user plane function in the home network. The other thing about this, we haven't talked about this yet, but signaling between a 5G system and the home system goes through this device now, this firewall, the SEP, Security Edge Protection Proxy. All signaling goes through a secure firewall. That's different from 2G, 3G, 4G. It's mandated in 5G that all signaling goes through this secure firewall called the SEP, Security Edge Protection Proxy. So this is, I know it's a lot of acronyms, and don't expect you to memorize all this. I just wanted to show you that through the generations, you have different signaling, different requirements. But remember, every generation has a user equipment, a RAN, and a core network. From 4G on, it's data only. And this is what we've done. This is what we talked about on day one. We said we're going to talk about mobile telecom basics. We're going to look at mobile identities. We're going to look at the different generations, and we're going to introduce some of these different signaling. And that's that. Questions? I know this was a lot. I know this was an awful lot, and don't expect. And maybe again, maybe we can work it out so I can come over there and we can do a complete 1 or 2 week class and really learn this stuff and learn it in a more concise way. But this was a lot, and I stop sharing and kind of move you over now to here. Now you're in front of me, and I want to thank all of you. I want to thank you very much for the last couple months and for coming in today on an extra day to finish this up. So I applaud. Maybe our paths will cross again. So
Yes.
thank you very much,
Yeah,
and
you too.
I've enjoyed
Thank
it.
you a
I've
lot.
enjoyed it very much.
We are completely the same, but
Yes. Hello.
Okay, thank you. And if you have any questions, Steve at cellulosys.com, I'll be glad to answer any of them. So thank you. Thank you very much.
Thank you, Steve. Thank you. We really appreciate having you here. Yeah. See you in the next cohort as well.